All right, so, I mean, zeros galore, so we'll work in the first row. So the determinant of A, matrix A, would be A1 multiplied by -1 raised to its position added. And then we'd be looking at these two guys.
Negative would never take. Oh, wait, never mind. You did it. It took like 10 seconds.
What's the? I can't remember the Q. Rada demonstratum? QED. I just can't remember the Q part. Whatever. I don't write QED. I think it's pretentious. So anyway, gimme. These kind of work themselves out because the only things that are multiplying to 24 are 4 and 6. The only things that are adding to 3 are 1 and 2. It's just a question of order. So that leaves you a 3 here, which means that this has to be either 2 or 4. Right? Since one of these entries here in the 30 multiplication has to be a 5, then that lower left-hand corner can't be a 5, and since the possibilities are 4 and 5 to get you to a 20, it has to be a 4. So then this guy is going to be a 2 by process of elimination, making this one a 5. All right? So that kind of gets you off to the races. What's left over in the bottom row would be 1, 5, and 6, which makes sense because that's got to get you to a 30. In the first column, you're left with a 1, 2, and 3. The only way you're getting to a 6 out of that, I'm sorry, 1, 2, 3, and 6. Okay, so forget what I was about to say. In the second column, you're left with a 1, a 3, a 4, and a 5. You can't repeat within a row or column, so it can't be 3 and 3. So to get to a 6, it could be, well, it has to be a 1 and 5 in some order because it can't be a 2 and 4 because 2 is already used. All right, so we have 3 and 4 left over, but I can't use 3. I'm sorry, I can't use 4 in dividing to equal a 3, so this has to be a 3, making this a 4. All right, that upper left-hand corner can either be a 2 or a 6, which, you know, it may be good news. We'll see in a second. This guy over here, to get to a quotient of 3, 1 or 9, 9's not possible. It's not in the domain, so it has to be a 1. The only way we were getting to a product of 6 using a 1 is if it were a 1 and a 6. That's not happening because I already used the 1. So this can't be, you know, you're thinking it's 1 and 6. It can't be that. So that means that this guy up here has to be the 6. So we're looking at 2 and 3, 2 and 3. You know, little notes help if you're not really comfortable with this stuff. Top row, 1, 2, and 3 are left over. I don't know much, but I know 2 has to be one of those entries. I just don't know where it's going. All right. But what that, you know, is going to kind of help me do is draw a conclusion over here somewhat, because one possibility, or a couple of possibilities, 1 and 2 or 2 and 4, the other is 3 and 6. So maybe that's going to flesh itself out in a second. We'll see. If you have a triangular region, somebody asked me yesterday, so I figure it's worth bringing up. If you have a triangular region, you can repeat within the region as long as it's not within the same row or column. So bear that in mind. Looking at the 7 plus, you have possibilities. It could be 1 and 6, but actually it can't because we already used the 6. It could be 2 and 5, but actually it can't because we've already used the 5. So 3 and 4 are the only possible pairings left over. 1 and 2 possibilities here. Now, sometimes you want to play the what-if game because in this triangular region we want to get to 48. If this is a 1, then somehow these two numbers have to multiply to equal 48. The smallest possible pairing that would get us to a 48 would be 6 and 8, but 8's outside the domain. So the 1's not going to fly. So it has to be, oh, crossed off the wrong one. So it has to be a 2. Now, if it's a 2, those other two numbers have to multiply to equal 24. Possible pairings would be 6 and 4. All right, but more importantly, because this is a 2, we're going to be able to figure out these guys. But also, I know that can't be a 2 up there. Making this one the 2. All right. Also, 3, 2. All right. So, working over here, the only possibilities left over for the 2 at the minus would be a 1 and a 5. But we already kind of fleshed that out somewhat. Assuming its possibilities are 1 and a 5, if it's a 5, well, maybe we haven't fleshed it out. If it's a 5, the other one would have to be a 3. If it's a 1, the other, well, maybe we did. If it's a 1, the other one has to be a 3. Either way, the other one has to be a 3. If that one's a 3, then this guy's got to be a 4, making this one a 3. All right. So in that first, or the rightmost column, we want to get to a quotient of 2. Okay. Possibilities would be the 3 and 6 combo, but not anymore because this is a 3. So it's either 1, 2, or 2 and 4. But I just said that this is the 2. This is the 2 here, so it can't be a 2 there. So that guy's got to be a 2.
It can't be the 4.
And it can't be a 4 because 4 is already used, so it has to be a 1. So this is a 5. So this is a 6. The only thing left over in the top row is a 3. Okay, so yeah, so we're pretty much there because we have a domino effect kicking in. Because if I gotta get to a product of 6, 1 and 6 isn't gonna work. I don't think. I'm sorry, 2 and 3 isn't gonna work because I already used the 2 and 3. So it has to be 1 and 6, but the 1 is used here. So 6, then a 1. Making this a 4 by process of elimination, making this a 5 by process of elimination. This is a 1. This is a 6. 4, 6, 5, 1, 4, 5. Possibly.